So dudes, yesterday, I know some of you guys were gone. Yesterday we talked about two super important things. Density, what's the definition of density? Mass over volume. We talked about pressure. The definition of pressure is force over area. You know, in everyday life, outside this room, we talk, it's PSI, right? Because you could measure force in pounds, and then you could measure area in square inches. That's referred to as pounds per square inch. But that's not metric. In physics, what do we use for pressure? Force is newtons, area, meter squared. What's a newton per meter squared called? Pascal. Okay? And you should know 1 atmosphere, which is what you're feeling right now just sitting in this room, is equivalent to 101,300 pascals. Okay, then for density, you should know we want mass in kilograms and volume in cubic meters. What's the most common liquid in the world? Water. It's an assumption. These fluid problems, it's just like when you were doing force problems. Did the problem have to tell you that gravity was 9.8? No, you just knew it was 9.8. In a similar sense, when you're doing fluid problems, the density of water is 1,000 kilograms per cubic meter. I was looking at the homework set just an hour ago, and I noticed that there were some homework problems that put it in the chemistry, the density of water in chemistry units. What's the chemistry unit? 1 gram per cubic centimeter. But these are identical. 1 gram per cubic centimeter is identical to 1,000 kilograms per cubic meter. Okay? So that's just background stuff you should know before doing fluid problems. Now let's talk about buoyancy. Okay, the key thing for buoyancy is Archimedes Principle. Archimedes Principle states that the buoyant force will always be equal to the weight of the displaced fluid. What's the equation for weight? W equals what? mg. Okay, that's be for the displaced fluid. Okay, so let's look. Here we have Mr. Wheeler. You guys recognize Mr. Wheeler there? And then there's a student in the back. I don't know that. I don't think I know her. Hopefully I don't. Because she'll probably hear this and be like, Spaldo doesn't know me? I don't think I know that kid. No, I think that's one of Greenberg. Anyway, so here's Wheeler with this student in a boat. So I'm going to draw. I'm not a very good artist, so I'm just going to do my boat like this. So here's the boat, little raft, and then the water's like this. You know, the boat is partway down in the water. Now, what are the forces that act on this boat? Well, the down force is what? mg, where that's going to be mass of the boat. So capital B is boat. Okay, and then what's the upward force? The buoyant force. So I'll do little b for buoyant. Little b for buoyant, big B for boat. Okay? Archimedes Principle tells us that this buoyant force is going to be equal to the weight of the displaced fluid, which in this case, what's the fluid? Water. Sometimes the fluid will be oil. Sometimes it'll be air. Air is a fluid. Sometimes it'll be helium. But so here it's water. So this is going to be mass of water times gravity. Okay, so then what you can do is sum the forces, just like you did back when you did Newton's second law. So we have the buoyant force up. So I'm just going to plug this in. The buoyant force is mass of water times gravity. And then down we have the weight of the boat, mass of boat times gravity. Sum of the forces equals ma, where that would be mass of boat, the total mass, you know, with Wheeler and the student and everything. Now what's the acceleration of the boat? 0, right? The boat's not accelerating. So then you're left with this equation. A very common thing that you're going to do in these problems is you're going to have to substitute in the density equation. So density equals mass over volume. So what's mass equal to? density times volume. So take this and you can plug it in there, right? And here, like if you didn't know the mass of the boat, you could plug it in there as well. But so then, then this equation, you would take out the mass of water, you would take out the mass of the water, and you would plug in density of water, volume of water, because that's equivalent to the mass. Now, final thought before we do a problem. What is the volume of this water? Volume of water. Do we mean the entire pool of water? What is this volume of water right here? The volume of the water is equal to what? The volume of the object displaced. The volume, or the volume of the object submerged, sorry, not displaced. The volume of the object submerged. So the easiest situation, guys, the easiest situation is when the whole object is submerged. The whole thing is submerged, then what would be true? The volume of the object equals the volume of the water, right? The trickier situation is when part of the object is sticking out of the water, like this boat right here. Only part of it's submerged. Does that make sense? All right, so let's do an example. All right, so here we have the boat again. So you're given the area of the bottom of the boat. The bottom of the boat is 0.96 meters squared. The total mass of the boat, including the boat, Mr. Wheeler, and the student, is 150 kilograms. So from this information, calculate buoyant force on the boat, which is the easy question. Number one should take you like 30 seconds to figure out, or less. Number one is very easy. The answer is 1,470 newtons. Number two is going to take some thought. Number two, how high up the side of the boat will the water come? So when the boat's in the water, so here's my boat. So the water, like that. What number two wants you to figure out is this dimension here. How high up the side of the boat will the water rise? What does this problem assume that you know? Density of water is 1,000 kilograms per cubic meter. All right, so take like 5 or 10 minutes. Oh, the answer to number two? The answer is 0.156 meters or 15.6 centimeters. Room will solve this. Number one is easy, number two is harder. Okay, so here's the boat. Okay, so the water's like this. The water level's like that. And in number two, we're being asked to find this, this H. How deep into the water does the boat settle? Oh, and we have the area. I didn't draw that very nicely. This area, top and bottom, are 0.96 meters squared. Okay, so we sum the forces. Well, first of all, let's do, what are the forces? The forces on this boat, we have mg down, where that's mass of boat times gravity, and then the upward force is the buoyant force. So we sum the forces. Summing the forces, we get buoyant force up, the weight of the boat down, equals ma, where that's mass of boat. Hey, in the problem set, there will be situations where the acceleration does not go to zero, like a stone dropped into a lake. If you drop a stone into the lake, are the forces going to cancel? No, because the buoyant force is not big enough to prevent it from sinking. So then you would have an acceleration. But here, there is no acceleration. That goes to zero. So what we're left with is buoyant force minus the weight of the boat equals zero. And we actually, let's see, number one, solve for buoyant force. mass of boat times gravity. The mass of the boat is 150 total with everybody in it and the boat itself. So this comes out as 1,470 newtons. That's the answer to number 1, the buoyant force. Okay, number 2 is trickier. So I'm going to delete this. So here's how you do number 2. So to do number 2, you have to realize the buoyant force always equals what? Weight of the displaced fluid. And in this problem, the fluid is water. So we'll say mass of water times gravity. Just realize in other problems, the fluid will be air, or helium, or nitrogen, or oil, but here it's water, okay? Now, what can we plug in for the mass of the water? Well, density is mass over volume, so what's mass going to be? Mass is density times volume, so plug that in right here. So this is going to become density of water, volume of water, times gravity. Okay, what's this volume of water? Is it the entire pool? No. What do we mean by the volume of the water? It's the volume of the water displaced, which is equal to what? The volume of the object submerged. It's this shaded area, right? This shaded area is the part that's displacing water. Is this upper part displacing water? No. So what's this volume going to be? The volume of the object submerged is going to be what? A times H, right? So let's plug this in. That goes right there. So now we have buoyant force equals density of water, A times H times G. So now you can solve for H. H is buoyant force over density of water, A, G. Fluids are tedious. Definitely tedious. Density of water is 1,000 kilograms per cubic meter. Area is 0.96. I'm out of room. Gravity is 9.8. H comes out to be 0.156 meters, or 15.6 centimeters. So by the way, did I already mention this is the whole reason we're building boats next semester? This topic, because I've had teachers ask me, like, you know, when the boat races start next semester, teachers are like, so cardboard boats, what does that have to do with physics? Well, what's the whole reason for the boat races? Buoyancy. And it's after the AP, and your brains are fried, and it's a good hands-on project. Definitely. But anyway, yeah, when teachers are like, cardboard boat, as if we're wasting time. No, dude, it's pure fun. It's awesome. You guys will enjoy it. You guys want to build boats? Yeah. It's Archimedes Principle. Okay, we're done.